Hello, the third tutorial in this series presents another set of pitch scale aspects in the Schillinger system of musical composition. You'll learn about the primary axis of a melodic continuity, key axis relations as determined by the tonality and modality, and about melodic modulations. I'll illustrate principles and techniques with application examples. This episode is part of a series on the theory of pitch scales from the Schillinger system of musical composition. We are looking at the first group of scales with a single root and a total range of up to 1 octave. This tutorial covers new aspects such as the primary axis of a melodic continuity, key axis relations, and techniques for melodic modulation. There will be more original examples. I'll summarize the essentials from part 1 and 2 in this series. The 2 Schillinger volumes on musical composition consist of a number of books, and you're now watching the theory of pitch scales covered in book 2. This tutorial covers chapter 4 from that book. We're still in the domain of the group 1 pitch scales, characterized by the single root and a compass of less than 1 octave. These scales typically have between 3 and 9 pitch units, and the first example shows the traditional 7-pitch diatonic scale on root C. The example at the bottom shows 3 permutations of a 4-pitch unit scale. In part 1, we created a melodic continuity from a set of melodic forms derived from the pitch scale and then overlaying a rhythmical pattern. These continuities lack several properties of a real and good melody, a topic covered in a separate Schillinger book. Here's an example continuity from part 2, based on a combination of melodic forms. It has an implicit melodic pitch curve, but there's a limited potential for obtaining a beautiful melody. Part 2 in the series was about the evolution of pitch scale styles. Starting from an original scale, we have several options for the evolution method. Scale families, derivative and partial scales involve techniques such as permutation, summation and subset selection, and will evolve into scales with increasing, constant or decreasing pitch unit numbers. The diagram on the right illustrates the process for obtaining a pitch scale family from a parent generation, with the result in staff notation below, where we see child generations with increasing numbers of pitch units. We continue with chapter 4 from the book, and you'll learn new aspects. The first is the notion of a primary axis. I'll show examples in a minute, but let's start with the definition. Consider a melodic continuity, an ordered sequence of pitches with durations. Now, for each pitch, determine the cumulative total duration. You will obtain a pitch probability density function, where the primary axis is the pitch unit that corresponds to the maximum value in the distribution profile, as shown here in the diagram. It acts as a sort of tonic, an anchoring point for the scale. Note that the primary axis may be equal to or different from the root degree. I'll show you a first example in detail. It is based on a minor pentatonic scale on root C. The melodic continuity uses 3 melodic forms, each an ordered set of all pitch units in the scale. Each melodic form is used only once in this example, but you may compose any combination and include multiple occurrences. Here you see the melodic continuity after applying a time rhythm, and we'll identify the primary axis after first constructing the distribution profile on the right. Start with the cumulative duration of the lowest pitch unit in the scale, here the root degree C. The time unit is the 8th note, and we find a total of 15T for this pitch, shown as a bar in the diagram. Repeat the process for the other 4 pitches in the pentatonic scale, starting with E flat and stopping at the highest pitch B flat. The distribution pattern has a maximum for C, so the root degree also is the primary axis of this musical theme. In the next example we use the same scale but modify the 3 melodic forms and continuity. overlaying an attack duration series, we obtain a gentle waltz played here by English horn. Again, we look at the cumulative duration of each pitch in the scale, and this time the distribution is different. The clear winner is the pitch unit G, not the root degree. It is the fifth above the root that acts as the primary axis, the predominant pitch. We'll revisit a number of melodic continuity examples from part 2 in the series and identify the primary axis. This melodic continuity in 6/8 meter was created from a pitch scale family and has a total of 6 pitch units. Doing the cumulative pitch duration calculations, we obtain a distribution profile with a 16th note as the time unit. The maximum value is for pitch F, which therefore is the primary axis of this phrase. It is followed in second position by the root degree C. Using a different generation combination from the same scale family yields this Allegro in 4/4. The pitch time distribution for the 7 pitches in the diagram on the right shows the predominant position of the pitch G. This and the previous example illustrate how a choice of the appropriate time rhythm that is superimposed on the melodic continuity will affect the primary axis pitch. It therefore is a design parameter when creating themes. This Andantino in 3/4 time signature is the last example based on the scale family. As stated in part 2, I was aiming for a key ambiguity B-flat major versus minor. The primary axis, as identified from the pitch duration diagram, however, is the root degree C. In second position we find the F, the fifth above the apparent root B-flat, which comes in third in the duration ranking. This Agitato melodic continuity uses a set of 5 derivative scales on the next higher degree and has a total of 5 pitch units. With the 16th note time unit, the cumulative duration puts pitch B-flat on top as the primary axis, summing the durations over 2 octaves. Once again, this is not the root degree of the original scale. Also created in part 2, this march theme is based on a set of derivative modal scales and uses all chromatic scale pitch classes. The design of this theme more or less hints at the key of C minor, a fact confirmed by the duration counts in the diagram that indicate the root degree as the primary axis. Using the interval permutation approach to pitch scale evolution yields this melodic continuity with a total of 10 different pitch units. The primary axis clearly is pitch G, not strange taking into account that most phrases end on a long duration note. On the other hand, this is in contrast with the many blue notes E-flat, G-flat and B-flat in this theme, where we would expect a more predominant role for the root degree C. If you prefer this pitch more in the foreground, a modification of the time rhythm is appropriate, asking for a redesign. This continuity, an Allegro deciso with key ambiguity was created from a set of partial scales through interval summation. Inspecting the pitch duration profile confirms that this time the designated key root A stands out as the primary axis, with the major and minor third, C sharp and C natural, ex aequo in second position. The final example from part 2 is this longer continuity, a Lento tranquilo in 3/4, again with a combination of partial scales. As was the case for the previous example, a simple 3-part harmony for strings has been added to the foreground melody. From the cumulative pitch duration plot, we conclude that the pitch unit F is the primary axis, confirming the design of this continuity around key root F. The distribution is fairly flat, with all pitches being used more or less equally long, except for the wrong note E natural, which is an error on my side, as I reported in the previous episode. All pitches may be interpreted as a specific degree of function in the key of F minor. Let's move on to the next aspect, the key axis, and, more importantly, the possible axis relations. To be honest, I find the Schillinger system definitions of root degree, tonic degree, primary axis versus key axis somewhat confusing. There is a single line definition of the key axis, without much explanation. It says that when we are dealing with a melody only, harmony being absent, the primary axis also is the key axis. The key axis becomes relevant when longer melodic continuities also involve a change of either tonality, that is, a key change, or move through different modal scale variants, or a combination of both. And therefore we may discern 4 possible axis relations, a concept that I will now illustrate with a simple example. Let's start with an original 6 pitch unit scale from group 1 and 2 modal variants starting on degrees D and G. And there you have it, my inevitable episode error. Pitch D5 should have been C. Apologies. The continuity is based on a single occurrence of 2 melodic forms MF1 and MF2 applied to the scale on root degree C. The total number of pitches is 12. The basic rhythm pattern is 3 plus 1 plus 2 plus 2 quarter notes. We synchronize this with the pitch sequence and therefore need 3 statements of the attack duration series. This is the example quasi-melody for demonstrating axis relations. Just for the fun of it, identify the theme's primary axis. The distribution shows peak duration for both C and G. In this case, I use the interval relation between these two and select C, since CG implies a 1-5 a tonic dominant degree relation. Listen to this Sarabande theme for French horn. And here is the reasoning when deciding on the axis relation type. Both phrases use the same scale on root degree C. The modal character is constant. We do not change the key and use the same set of pitch units throughout the continuity. Therefore, this theme is labeled as Unitonal-Unimodal. Let's use a modal derivative scale variant PSD1 for melodic form 2. This means that the axis relation becomes polymodal. The key has not changed, since we use the same set of 6 pitch units from the original scale. There's a change in the primary axis. The distribution shows the same peak value for B flat and D, and forgive me for the wrong pitch in MF2. So now again I use the root third property of the B flat D interval in order to label the B flat as the predominant pitch. The Sarabande is seen here with a key change from melodic form MF2, which is the original pitch scale PSD0 transposed to root degree E flat. So the modality remains constant while there is a change of key, and the axis relation therefore is Polytonal-Unimodal. The final relation type is shown here, where we use the modal derivative scale PSD3 transposed to the key of E flat for the second melodic form. This is a Polytonal-Polymodal example, the fourth option. As the final subject of this tutorial, let's turn our attention to melodic modulation, which is relevant for polytonal axis relations. Melodic modulation implies that we insert a transition section between two phrases of a melodic continuity that are in different keys. There are 3 techniques for moving from the source to the destination key. Again, I will demonstrate these with a single example, but on my channel there is an older tutorial dedicated exclusively to melodic modulation. Let's design the example using this 6 pitch unit scale, where root degree C is the starting point, and we transpose this scale up by 3 semitones to the target key of E flat. The melodic continuity uses a combination of 4 melodic forms, all as single occurrence. I'll use the pitch class diagram for illustrating melodic modulation techniques, taking into account that the original scale corresponds to pitch class set 625 shown here. Both scales are depicted as white inner ring circles on root C and as yellow pitch class dots on the outer ring for the destination key E flat. The first modulation technique uses the common pitch units between the scales. Inspect the diagram and you'll easily detect the overlapping pitches C, D and A, marked with a green ellipse and shown here in staff notation. Here's the full example for the common unit modulation technique. After overlaying a rhythm, we use the same continuity in the source and destination key, although in the audio example you'll notice the different orchestration. We insert a transition phrase to achieve a smooth modulation. In case of a common unit modulation approach, you should create motifs from the overlapping pitches, use a rhythmic pattern from near the end of the continuity, make the transition long enough to disassociate from the starting key root, and If the new root is part of the common unit set, avoid its use. That is not the case here, since E flat is not an overlapping pitch. Listen to the result. The second method is based on a set of chromatic alterations that may be identified when comparing the source and destination key. This set has been marked in the pitch class diagram with arrows and is shown here in staff notation, where D moves to E flat, F sharp to F natural, and B natural to B flat. We create a different transition section using the following Schillinger recipe. Use combinations from the chromatic alteration pitch pairs. Use long durations exposing each alteration. Continue from the final chromatic alteration by proceeding stepwise to the next pitch unit in the destination scale. In our example, we move from B natural through B flat and then to A. Listen to this alternative modulation solution. Note that the transitions are based on melodic material only. There is no harmony involved. Schillinger provides this unique and valuable toolbox for creating meaningful transitions. His final method uses identical motifs. This means that we select a characteristic motif from the end of the source continuity. It is marked here with an orange-colored frame. During the transition, we develop a set of motif variants. This implies that the variation incorporates an altered pitch from the destination scale, or we repeat a motif at the next lower or higher degree in the new scale. The transitory motifs are shown here as green frames. Listen to this third melodic modulation approach and notice that I've used frequent octave transposition of individual phrases in this continuity. In summary, this tutorial is about specific aspects of Group 1 pitch scales in the Schillinger system of musical composition that are relevant when creating longer melodic continuities and connecting phrases. You saw the method for identifying the primary axis degree of a scale. Use this as an awareness or design tool when implementing a time rhythm in a melodic continuity and obtaining the predominant pitch, it may be different from the scale root. A longer melodic continuity with multiple phrases may involve a key change or a combination of different modal derivative scales. Therefore, we may discern 4 possible key axis relations. In case of a polytonal continuity, you may connect phrases in different keys more or less smoothly with a melodic modulation section. Schillinger provides 3 alternative methods that use either common units, that is, overlapping pitches between source and destination key, chromatic alterations, or through identical motifs. The numerous original examples not found in the Schillinger books will help you incorporating these techniques in your personal composition process. Which concludes this series on Group 1 pitch scales. Please give this video a like and subscribe to the channel. Embed links to these tutorials and help increasing the channel visibility. In the description below there's a link to the PayPal donation button. Or maybe you have other ideas for supporting my online education efforts. Just let me know. Visit the website for more content or purchase ebooks. As always, thanks for watching.